Hey everyone, welcome to this explainer. I am absolutely thrilled you're joining me today because, well, we have a truly groundbreaking piece of research to unpack. We're going to be diving deep into a fascinating new paper out of NVIDIA. It's called ARDY, autoregressive diffusion with hybrid representation for interactive human motion generation. Yeah, it's a mouthful, but if you've ever wondered how video game characters move so fluidly or how we might actually train humanoid robots to navigate the real world, you are going to love the concepts we're covering today. Let's just get right into it.
Everything we're looking at today stems from one seemingly simple question. How do we create realistic 3D human motion in real time? Now, you might be thinking, isn't that just a fun puzzle for game developers? But actually, no. This is a massive, industry-defining challenge. Being able to generate believable, physically accurate, and highly responsive human motion on the fly, that is absolutely crucial for the future of interactive animation, complex virtual simulations, and the rapidly growing field of humanoid robotics. We literally need digital humans and robots that can react to us instantly, without looking like, clunky animatronics.
Okay, so here's our roadmap for today. First, we'll look at the motion generation dilemma. Then, introducing ARDY. Third, how ARDY actually works. Fourth, we'll look at the training and benchmarking. And finally, number 5, the interactive future.
Starting off with Section 1, the motion generation dilemma. This is the core challenge.
So to truly appreciate what NVIDIA has achieved here, we really have to understand the frankly frustrating status quo that animators and engineers are facing today. The core issue is this severe trade-off between exact control and processing speed. It's your classic, you can't have your cake and eat it too situation. Up until now, developers have essentially been forced to choose between two highly flawed approaches to 3D motion synthesis. It's like, if you want the motion perfectly tailored to your exact instructions, you completely sacrifice the ability to generate it quickly. But if you want it fast, well, you kind of lose your grip on the steering wheel.
Let's break those two paths down. On the offline method side, sure, you get precise control. You can use complex text prompts and specific kinematic constraints, like you can tell a character exactly where to place their foot right before they jump, but they completely lack real-time inference speed. Think of it like rendering a massive Hollywood animated movie. They have to process the entire sequence all at once, which makes it totally useless for a live video game or a reactive robot. Then, on the other hand, we have online methods. These offer that fast, real-time synthesis we're craving, but they sacrifice controllability. Because they're generating motion on the fly with super limited context windows, they really struggle to understand complex text semantics or, hit long horizon goals. So they're incredibly fast, but unfortunately, they're kind of sloppy and short-sighted.
Moving on to Section 2, introducing ARDY, the ultimate solution.
All right, it's time to reveal the hero of our story, the framework that actually bridges the gap between those two frustrating extremes, ARDY. Now, ARDY is defined as a streaming generation framework that enables real-time, high-fidelity 3D human motion generation with text and kinematic constraint control. The really operative words here are streaming and control. It finally brings together the lightning-fast online prompting speed that interactive apps demand with the flexible, long-horizon kinematic constraints that offline models get to enjoy. It is quite literally the best of both worlds, packaged perfectly into a single cohesive system. But how exactly does it do this?
Let's look under the hood in Section 3, how ARDY works.
So there are two major architectural breakthroughs making this real-time magic possible. The first one is what the researchers call a hybrid representation. Basically, instead of trying to process the entire 3D human body as one massive, complicated data stream, ARDY dynamically splits the human motion into two distinct components. First up, we have explicit root features. You can think of this as the character's core trajectory, so their center of mass physically moving through 3D space. Then, secondly, we have a latent body embedding. This takes all the complex, high-dimensional data of the limbs, like the subtle swinging of arms or the bending of knees, and compresses it. It's kind of like efficiently packing a suitcase, right? It compresses all that complex data into a highly efficient learned format without actually losing what's inside. And what's genuinely fascinating about this specific hybrid split is how it gives ARDY its unique superpowers. By keeping the root features explicit, ARDY allows developers to maintain precise trajectory control. You can easily steer the character exactly where you want them to go in the environment. But by packing the rest of the body into that efficient latent embedding, ARDY enables incredibly fast generative learning. The AI doesn't get bogged down calculating every single finger joint in real time. Instead, it intuitively relies on its learned understanding of human biomechanics to just naturally fill in those details, all while perfectly following that explicit path you set. Now, the second major innovation is the engine itself, a two-stage autoregressive transformer denoiser.
Let's de-jargonize this a bit. Autoregressive simply means it predicts the next frame of motion based on the previous frames. But here's the kicker. It doesn't just look at a fixed window of the past. As step 1 shows, it processes a variable history context. This means ARDY dynamically decides exactly how much past information it needs to look at to make a good prediction, which gives it just incredible flexibility. Then, in step 2, it conditions that prediction on flexible long-horizon kinematic constraints. So it effectively looks at the past, looks way into the future at your desired goal, and then perfectly denoises, or refines, the current frame of motion to smoothly connect the two. It's brilliant.
That brings us to section 4, training and benchmarking. How do we prove this works? Because, a great design is nothing without the data to back it up. The secret to ARDY's success lies heavily in its training regimen. The model was trained on massive, large-scale motion capture datasets. But what is absolutely crucial here is how it was trained. It was directly conditioned on text labels and kinematic constraints sampled right from the ground truth poses. Because ARDY was natively trained to associate specific text commands and specific bodily constraints with highly accurate motion capture data, it inherently understands how to generate controllable motion. So it didn't just learn how humans move, it learned how to move when told to do specific things.
And to actually prove this, the NVIDIA team put ARDY through its paces using 2 incredibly rigorous datasets. On one side, they used the Human ML3D benchmark. That's basically the gold standard testing ground for text-to-motion generation. Then on the other side, they utilized the Bones RigPlay dataset, which allows for large-scale, exceptionally high-fidelity evaluation of the actual physical constraints. And it's one thing to pass a standard test, right? But it is an entirely different achievement to excel when the physical fidelity is turned up to the absolute maximum.
And the results from all these extensive evaluations yielded a pretty definitive conclusion from the researchers. They state that the tests demonstrate ARDY's high motion quality and constraint adherence, validating the efficacy of our key architectural decisions. In plain terms, it worked. The hybrid representation and that autoaggressive denoiser officially solved the motion dilemma we outlined earlier. The model generates incredibly high-quality motion, and it actually listens to the constraints given to it, with the whole shebang happening completely in real time.
Let's transition to our final section, number 5, the interactive future.
So, what does this actually mean for the person holding the controller? The crucial point here is how ARDY's variable history context and hybrid representation translate into actual usable features. With ARDY, you get dynamic text control. You can literally change the prompt mid-stride and the character will naturally transition. You can set diverse keyframe pose constraints, like forcing a character to duck under a specific obstacle. You can draw a path for them to follow. And honestly, most excitingly, you can achieve interactive locomotion just using a mouse and keyboard. You can steer a fully 3D biomechanically accurate character seamlessly with standard inputs, and the AI just handles the physics of the movement in real time. No way, right? It's incredible.
And hey, you don't just have to take my word for it. For the focused learners out there who really want to get their hands dirty, supplementary video results, the underlying code, and the actual model releases are available right now at NVIDIA's research project page. Seeing the instantaneous responsiveness of the AI is mind-blowing. It is seriously so satisfying to watch the demo videos and see how instantly responsive the character is to user inputs. I highly recommend checking it out. So all of this builds into our final thought for today. We started by looking at a severe limitation in the industry, that frustrating choice between speed and control. Well, ARDY has shattered that limitation. By cleverly dividing the representation of the body and completely rethinking how an AI looks at past and future context, NVIDIA has given us an incredible new tool. So the question I want to leave you with today is this. With limitless, real-time motion generation now a reality, what will you build next? The boundaries of interactive digital environments just got pushed way, way back, and I absolutely cannot wait to see what happens. Thank you so much for exploring this with me today.